So we have gone through the thought process or the concept that pandas has in terms of treating the two-dimensional data frame. And likewise, it's the same, and it becomes easier when we talk about series, because series is just, by the position, that's all. Um, Series also has labels, much like data frame, but it's much easier to understand once you understand the data frame concept. So now let's move on to see how we can twiddle by getting and setting the data by address. So we learned how to read back the cell values, the contents, by using .log, all right, and .ilog, like that. So data frame, this data frame, .log, uh, square bracket, because that's required. And then we say 0, 1, 2, 0, 1, 2. And then also the two columns, C and D. So this is how we describe this colored yellow box. So we are referring to this 3x2 rectangular segment within the big data frame. This is how we are able to subset any part, anywhere at all in the data frame. So because C and D, they are consecutive, and what if it is C, D, E, F, G, very long, right? And they're all consecutive. There's an easier way. We can simply say C colon D. C colon D. Let me start from C, end at D. Now, be very careful there. This is .log, all right? This C colon D, they are inclusive. In particular, the ending value here is inclusive. Now, you might not find it too surprising. It's like, oh, yeah, of course, right? But if you think about the range that we talked about last time, using the range function for I in range 5, you know that I will run from 0, 1, 2, 3, 4, and 5 is never included. So the end value is never included. And that behavior is pretty dominant in Python and all Python related libraries and famous libraries, standard libraries, popular libraries, all follow the similar kind of understanding, so that it is the learning curve is easier, right? Here, pandas is not trying to be the odd one out here. It's because it's just a short form way of listing everything, right? Because we really want C, we should list it out. We want D, we list it out. And the short form must behave like that, because otherwise it's hard to know D plus 1, what is that, right? What's the label next to D? It may not be E, it may be X, we don't know, right? So it becomes much harder to do things if you insist it has to follow the Python way. So this is inclusive. Much in the same way, we can do a 0 colon 2, because the row labels, remember labels, they happen to be also consecutive. So pandas is pretty smart. It's able to understand that 0, 2, right? So I will iterate through 0, 1, and 2 inclusively, because of the .log. Let me emphasize again. .log interprets the endpoints inclusively. So it's not going to change the bigger Python settings, as opposed to .ilog. Okay, .ilog. ilog is going to obey the Python convention. So in other words, if we want back the same yellow rectangle subset here, we'll have to list the row range from 0 to colon, not 2, but 3, because 3 is not included, so it will list 0, 1, 2. All right, so this is where things start to get frustrating if you kind of didn't know it. And it will be very, very frustrating. It's like, I did follow Python's way, right? I did put in 0 colon 3. Why did it include an extra row? Something like that. Yeah. So here, .ilog, because it's integer reference, is behaving exactly like range. So same thing, we want to specify 0, 1, 2, 3, 4, 5, 6, 7. I want 7 and 8 So I must end at 9, which is now not included. So same thing here. Okay, so this is the equivalent for I log. The nice thing about this is that when we refer to this on the right hand side, if we say something like y equals to df.ilog, x equals to df.log, we would end up getting the read effect, the get effect. So we read and we assign, right? What if we want to assign something, like assign the value 999, okay, throughout all the cells here? Very simple. If you can successfully describe this for getting, then you simply place the same on the left hand side of equal sign, and then that's it. You can now assign anything, all right, to this yellow segment. So if we just say equals to 555, then all the cells here will be immediately set with the values 555. So same thing goes for df.log, which is making it super powerful and very convenient, because if we can read from it, then the same thing moves to the left, we can assign back to it. This is by no means easy from the implementation part of Python. It's going to take some smart coding to understand what you're trying to say when you move the whole expression to the left hand side of the equal sign. But it's done, so let's just enjoy that convenience, right? So this is very descriptive, and because it is based on the slicing concept, we don't necessarily just have to range it. We can also do a stepping. So we have the beginning, jump by steps of 6, ending at the last no, sorry, I take it back. The starting from 0, ending at 6, jump by steps of 3. Okay, so uh, that's the row, and then we have beginning at 1, column 1, because it's .ilog, remember, ending at 9 exclusively, not inclusive of 9, jumping by steps of 4. So what does it mean? The row means starts at 0, okay, starts at 0, jump by steps of 3 until we hit just before 6. So 1, 2, 3. We want this row as well. 1, 2, 3. But we cannot hit 6, so we shouldn't include that. So that's it. And so we want only this row and this row. Which columns? Well, start at 0 and 1. So start here. We want this column, jump by 1, 2, 3, 4. We want this column, jump by 1, 2, 3, 4. Right, but this is 2, 3, 4, 5, and 6, 7, 8, 9. We just hit 9, but we are not supposed to include 9. So we stop there, but that means don't include 9. So end up we are selecting not all the cells here, only these 4 yellow colored cells. Do you notice that? We are only selecting these 4 corners of the cells by simply using a clever slicing convention to denote what we want. And of course, if we extend the 6 and the 9 to 60 and 90, then we could actually pick up all the spots in a very regular manner, in a very compact way. All right. So if we move this extraction to the left-hand side, it becomes assignment. Instead of getting on the right-hand side, on the left side, it becomes setting. So we like to set all these corner yellow blocks to 999. And the way to do it, that's it. This is it. Very simple. Okay, very powerful. And assignment and extraction, simple as left-hand side, right-hand side. Now, at this point, it's probably good to learn another similar tweens of commands, and they are called at and I at. So hopefully by now you get the idea. The at is simply like log. So the values are row and column, but they only admit one row and one column. So the at is like, I want to read or write that cell, one cell only. Now, since we can always use log to achieve one cell or many cells, Why don't we just stick with log? Now, two things, right? Two reasons. The at and the corresponding I at. The I at will be referencing not by labels, but by the absolute positions. So I hope by now it's all clear. They are just referring to the invisible, but definitely their position integers. So the at and I at, their behavior definitely can be done by log and ilog. There's no doubt, no question about that. So why having these two seemingly a bit redundant methods, right?